So next concept is force on a current carrying conductor in a magnetic field. So now we will discuss the how force is exerted on a current carrying conductor when it is placed in a magnetic field. So we know that when you place the current carrying conductor in magnetic field, so it will exert an force. But the French scientist André Marie Ampere, they found that when you place the magnet in a magnetic field, the magnet must also exert an equal and opposite force on the current carrying conductor. So now let us do one activity. So how the magnet will exert a equal and opposite force on a current carrying conductor. So see this one, this is the aluminium rod placed horizontally and this one is suspended by using some stand. And this aluminium rod is placed in between the horseshoe magnet. This one is magnet, this is north pole, this is south pole. And this rod is connected to the battery and the switch. When a switch is closed, so the battery will provide the current and current is passing through this circuit and this aluminium rod behaves as a magnet. So when it behaves as a magnet, so here also there is a magnet. So there is an attractive or repulsive force is exerted between these two one. So this aluminium rod is displaced towards left. When this aluminium rod is displaced to this left, this one is connected to the negative terminal of the battery. Remember that. Okay. So if you reverse this one, now write the positive, then write the negative. Okay, then connecting this one. So now the rod is displaced towards right. Why the rod is displaced towards right or left? It's a very simple, because the aluminium rod here, in the activity, the aluminium rod exerts a force on the current carrying conductor when it is placed in a magnetic field. Okay, and one more thing here, if you reverse the current or if you change the direction of the current, the direction of the field is also changes and direction of the force is also changes. So from this activity we can conclude that the direction of the force depends upon the direction of the current and direction of the magnetic field. Why? When you change the direction of the current, here the displacement of rod is also changes. That means field is also changes and its force is also changes. It means its direction of the field is also changes, direction of the force is also changes when you change the direction of the current. Okay, so this one here, the direction of the force and the field and the force. Remember, force, field and current are mutually perpendicular to each other. So this one is explained by the simple rule. The rule is called Fleming left hand rule. So see this one, this is the Fleming left hand rule. Okay, here first according to this rule, first press the thumb, this is forefinger and middle finger of your left hand, and these three fingers are mutually perpendicular to each other. Okay, in the first finger, this one is represent the direction of the field. This middle finger is represent the direction of the current and thumb is represent the direction of the force. Okay, and see this one diagram, this is the field, this is the force, this is the current. This is the Fleming left hand rule and very important one. Okay, the Fleming left hand rule is very important one. And one more thing here, the use of current carrying conductors and magnetic fields, or these are uses in some devices. The devices are electric motor, see this one, electric motor, electric generator, loudspeakers, microphones and measuring instruments. So in this chapter we will discuss the electric motor and electric generator. Okay, so I will explain the important questions on electric motor and electric generator. See this one, this is the electric motor. Here they use the magnetic field and current carrying conductor. Here the current carrying conductor is ABCD. This is the coil ABCD is the insulated wire. Okay, this is the rectangular coil. This is placed in between the two magnetic poles, that is north and south. This will produce the magnetic field. Okay, and one more thing here, this AB and CD are perpendicular to the direction of the magnetic field. Okay, this is the electric motor, important one. So in this you should learn the how to write this electric motor. So ಇದನ್ನ ನಿಮಗೆ ಕ್ವಶನ್ಸ್ ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ ಪಕ್ಕ 3 ಮಾರ್ಕ್ಸಿಗೆ ಈ ಡಯಾಗ್ರಾಮನ್ನು, ಎಲೆಕ್ಟ್ರಿಕ್ ಮೋಟರ್, ಎಲೆಕ್ಟ್ರಿಕ್ ಜನರೇಟರ್. ಸೊ ಎರಡರಲ್ಲಿ ಒಂದು ಪಕ್ಕ ಬರುತ್ತೆ. ಸೊ ಇದನ್ನು ನೀಟಾಗಿ ಡ್ರಾ ಮಾಡೋದನ್ನು ಕಲ್ತಿರಿ. ಓಕೆ.